Hello everyone. We're going to wait just few more minutes until everybody joins. We're still having more people in the queue. Please bear with us and we'll continue shortly. Okay, I think we're ready to go. So first of all, thank you very much for joining. At badminton.com, we believe in evidence-based approach to performance and coaching in badminton. And our first webinar focuses on performance as injury prevention in other sports and what could we learn and transfer to badminton. Before we move to the agenda, I would like very shortly to present our speakers, to whom I'm very thankful. First, Professor Mark King. Mark is a professor of sport biomechanics in Loughborough University, and his research combines theoretical and experimental technique in biomechanics and pushes the boundary to perform in sport. Dr. Pete Alway. Pete is a research associate in sports science at the University of Loughborough. His research focuses on understanding the risk factors and injuries in cricket and fast bowlers specifically. He will go in details more about the research and how to adapt the physical activities. Harley Toller is a former British badminton player and a current PhD candidate at Loughborough University. His research focuses on to links the racket technique and performance for the badminton smash. And no pressure on Harley, but we are very happy and hopefully achieving a new world record speed in the badminton smash. And myself, Stefan Lutzkanov, as a professional badminton coach, I have an experience in elite coaching from Denmark and Germany. And currently I'm a PhD student in Loughborough University as well. Our agenda for today, Harley would present us with an intro, how that relates to badminton. We'll move further with Professor King, inform us a little bit about the performance in sport, in different sports. We'll follow with Dr. Alway and injury prevention. And I will summarize and show you a little bit about our conception of badminton at the end. Of course, we'll have Q&A, which will be minimum 10 minutes. It could be more according to the interest. And from now on, I can ask you if you have any questions in advance. While we're presenting, please don't hesitate to put them in the Q&A. We'll try to publish or answer as fast as we can. And I would like to welcome our first presenter, Harley. Harley, please feel free to unmute yourself and share the presentation.
Okay, thanks, Stefan, and thanks everyone for joining today. I hope you find the webinar useful and insightful. So a very quick introduction to me. So like Stefan said, I'm a former GB badminton player. So I trained at the National Badminton Centre in England for 3 years, competing at an international level. So that's me at the All England Championships around 5 or 6 years ago. Now I'm in the process of finishing my PhD at Loughborough University, mainly focused on the biomechanics of the badminton smash, so looking at optimal technique and how people smash fast. And also alongside that, looking a little bit at the racket behaviour, how the racket mechanical properties influence performance alongside the technique. And my talk today is going to look at how and perhaps why we should use a more evidence-based approach to performance and coaching in badminton, and hope to provide some rationale for the discussion today. So what is the current state of play in badminton? So from my experience within playing badminton and also coaching in badminton, most coaching is based around that coach's past playing or coaching experience, so relatively subjective in nature. There'll be certain high performance systems where there is a level of sports science involvement. So here at Loughborough, for example, there's a sports science team, physiologist, strength conditioning. So there is some level of sports science involvement, but relatively speaking, especially across the developmental stages, there's not a whole load of science and evidence-based practice. What I would like to see happen more within badminton is coaches starting to challenge what they themselves know, challenge potential biases they might have based on that subjective approach, and also challenge generally what is known within badminton. So seeking and kind of driving new questions within badminton that hopefully science can answer. And we'll see later on how other sports have asked questions and ultimately how science has answered those. So within badminton, with it being a very complex sport, there's lots of kind of broad and generic questions that we could answer. So looking at movement and injury risks, how we can manage those injury risks, looking at performance and technique. So whether that's looking at how technique changes throughout a player's development from junior to senior, whether that's looking at technique between male versus female, single versus doubles. So there's lots and lots of questions that we could ask in badminton, but that haven't been answered yet. And hopefully in the future, those questions and more questions can be answered. So what we'd like to do with badminton is develop, create a scientific, systematic and structural basis for all these different aspects of badminton. So whether that's the technical side, tactical, physical conditioning, movement injury, psychology, all these different components, trying to really break them down into their core fundamental components where we can start to build understanding, knowledge base and deliver that to coaches, so that ultimately the coaching is better, sports science involvement is better, and ultimately the performance is better from the players. So ultimately looking at how we can use science to better performance. So a very quick introduction to badminton. So the primary goal is to provide evidence-based content for coaches, players and administrators or anyone involved within performance badminton. So moving away from that relatively subjective approach to this more research-led, evidence-based approach. Secondary to that, provide a platform for external coaches, scientists, other parties, where they can provide and disseminate their content and knowledge. So how do we plan to deliver that? So we plan to create a series of short course content on all those different topic areas I mentioned before, and depending on that topic area, that will influence how that is delivered. So if it's quite informational or scientific, similar to today, a webinar or lecture style delivery. If it's a more on-court, technical, tactical topic area, looking more at on-court video demonstrations. And then in terms of external coaches, scientists providing their own content, we would look to work with them and ensure that that content is of the required quality and essentially provide some validation on that content. Okay, so moving on, Mark King is going to talk about his research on performance and optimizing performance in cricket and gymnastics and how we can hopefully apply that to badminton. So over to you, Mark.
Thank you, Harley, and it's a pleasure to see everybody or meet everybody today. So I'm a professor here at Loughborough University. I've been here at Loughborough for over 30 years now, and I came because I love sport and my main sport was badminton. I was nowhere near as successful as someone like me, but I have had some success as a veteran, and there's a little picture of me there. Anyway, I'm a biomechanist. And like many of the people on this call today, that's our discipline area. But what is biomechanics? Well, biomechanics is to do with mechanics and maths, although there's not going to be any equations, so don't worry in this presentation. We'll show everything through visuals, but we use maths and mechanics to explain movement in sport. And we try and look for factors that are important from either a performance perspective, which is what I will talk about, but also then from an injury perspective, and Pete will touch on that afterwards. My philosophy as a biomechanist is that there are some factors that are critical for elite performance, but there are lots of other things that aren't, and that could be due to coaching, individual variation, etc. And as a biomechanist, as a starting point, we're really trying to understand those factors that are critical. What allows our elite players to perform so much better than everybody else? Think about the jump smash. Something we've done some work on here, and I'm sure it will be the topic of a full webinar in due course. If you look at this graphical sequence, if you're a coach or a player or etc., what do you think? How could you improve this performance? How important is strength to this athlete's performance? Do the best players, have they got the biggest biceps? Or is it something to do with technique? And then if we think about this player, could you improve their performance, or is this their limit? Then how, if we took a range of athletes, maybe male and female, younger, older, etc., how does optimum technique change for them, or is it actually the same? These are all really challenging questions, and every coach will have an opinion. But as a biomechanist, we try and use science to understand and help support coaches in their delivery of trying to help athletes improve their performance. So it's that integration of what we can understand scientifically with the practical side. Well, we're not going to talk particularly about badminton here in the examples, but I'll try and relate it back to badminton. But we're going to see what can we learn from other sports where they've done more research and more science than we have in badminton. And we've worked very closely with the England cricket team over the last 15 years. So I'm going to start with fast bowling in cricket, and then we'll look at a more theoretical example in gymnastics. So not all of you will be familiar with fast bowling, but essentially the performer runs up and bowls the ball as fast as possible. And this clip is taken at the National Cricket Performance Centre here at Loughborough, set up as a biomechanics lab. And so the faster they can bowl, the better, within reason. So this is the environment. So this is turning the cricket centre into a biomechanics lab, but they can still perform naturally in an indoor setting. And we've been really fortunate to have access to some of the best performers in the world working with England. But we have to stick reflective markers on them, and this is the current state of technology in biomechanics where we can accurately see what someone does. So here you see us tracking the markers, and we're not going to go into any detail here, but we can essentially track what the player does. We can then make it look a bit more realistic, just like you saw for the badminton smash. We can see the same here for bowling. So if we took a cohort of bowlers, all elite, but a variation of maybe 10 or 15 miles per hour in bowling speed, what would the fastest bowlers do in that cohort? Well, perhaps not surprising, the first technique factor that comes is that the ones that bowl faster run up quicker. So we saw at the beginning of this movement there's a run up, not like the badminton smash, but a run up, and those that bowl quicker run up faster on average. A more interesting and perhaps more relevant factor to the badminton smash is the second one, which is the position of the bowling arm midway through the bowling action. And faster bowlers delay the onset of bringing the arm through. So the bowler on the right is bowling considerably quicker than the bowler on the left in this picture. The third factor is that speed doesn't come from the arm necessarily, but comes from driving the trunk through. So this is from the left to right, the trunk being brought forward through a bigger angle, and that's linked to pace. So this is between front foot contact and ball release. So the bowlers that bowl faster drive their trunk through, and then that pulls the arm through. They don't just pull the arm through. And then the last factor that comes out as being critical to performance is the front leg. And those that collapse like the bowler on the left don't bowl as quick as the bowler on the right, who managed to brace that front leg and at ball release has a straight leg. So only those four factors, ignoring all other characteristics, explain the majority of the variance in ball speed. If you put that together in a video clip, here's the much quicker bowler on the right, and the proportionally slower but still elite bowler on the left. And we can see those four factors coming through. Now, another thing that the coaches talk about is a shape when we're coaching. And although I'm a biomechanist, we integrate with the coaches here. And this shape at ball release and this one attribute, that position of the shoulder at ball release, really explain the most variance as a single factor. Whereas the bowler on the left here looks like he's pulling his arm through because this angle is smaller, this bowler here, who's the fastest in the cohort, is driving his trunk through and leaving his arm behind. So we start to mechanically understand where pace comes from. Well, remember the jump smash that we're also passionate about? How might that link to that? Well, could we identify what the characteristics are for the smash, similar to what we've just done in cricket? Could we do a similar process? And that's what Harley and others are doing at the moment, and that will be the topic of a future webinar. Perhaps you have your own ideas. Maybe you think about internal rotation of the shoulder, pronation of the forearm, or movement of the trunk. Would they explain the majority of the variance in speed? And then if we took a range of individuals, would we see those same technique characteristics come out, or would it be different based on maybe their strength profiles or their age or their gender? These are all questions that we could answer using that sort of methodology, and certainly we're certainly well on the road to answering some of them, and in the future we'll do more. So that's an experimental approach to understanding performance in sport. But what about a different sport and a different approach in biomechanics? So this is gymnastics and a double layout somersault. So two somersaults in a relatively straight position. And for a gymnast, this is a relatively maximal move. They can't do much more than this. So with all good research problems or questions, they start with a question. Well, instead of doing two somersaults here, would it ever be possible to do three? And this would be the equivalent in the smash of saying, could you smash 25% faster, perhaps? What would it take to achieve that? Well, for the triple layout to be possible, is it simply take that gymnast and change his technique? Or do I need to make him really strong? Or do I need to change something else, perhaps how he runs up? Well, these are really difficult questions to answer experimentally, because the elite gymnast probably isn't willing to mess around with his technique too much, hasn't got time to go to the gym, etc. But if we use a computer environment, we can answer these questions using a theoretical approach. I'm not going to go into the detail, but in essence, this picture at the bottom is going to be representing the computer model. So this is completely theoretical, and the video at the top here is the performance. And the first thing for us to do is to show that the model can do what the athlete did. So here's the computer simulation at the bottom, being able to reproduce what the athlete does. And once we can do that, we don't need the performance at the top. We can then just use the model at the bottom and answer these what-if questions. Could we do a triple layout? So our first optimization, so it's a mathematical optimization, is if you take the same performance, the actual strength and initial conditions, and said, just change your technique, use your muscles in a different way, the ones you've already got. Could you do a triple layout? And what we find is that instead of 2 somersaults, the model does 2 somersaults. And this was a really reassuring result, because if you've got an elite gymnast, as we had here, that spent 10 years optimizing their performance, it would be very surprising if mathematically we could show just with a change of technique, they could improve their performance dramatically. So this supports that the model works. So the second optimization is this, okay, is it all about strength? Are the strongest athletes the best? Well, if we make the model as strong as we dare, and then ask the model to then find the best performance with that increase in strength, what do we get? And we find instead of 2 somersaults, oops, we get 2.5, which is no good to anybody. And what we find in gymnastics and tumbling is that strength isn't the limiting factor. It was a good job we didn't do this experimentally. Then we go back to the original strength and said, okay, tumblers run up a lot faster than gymnasts. In fact, we can increase that run-up speed by 50% and still use the same sort of movement timings. Tumbling is still possible with that sort of run-up speed. And if we do that, what we find, we ask the model to do the best it can. Instead of 2 somersaults, it does manage to do 3. Well, when I did this work quite a number of years ago, nobody in the world was doing this, but it theoretically was possible. So I was left thinking, is this realistic? Can a computer model really predict the limits of human movement? Well, some years later, I got sent a couple of examples of people doing this, and here's one of them. You'll notice the gymnast runs up really fast, generates angular momentum, and at the end of the sequence produces a triple layout in a very similar way to what I theoretically predicted. So here's this marrying up of a theoretical computer model with what is actually possible for a human. Where do I want to take this work? Back to my badminton days and back onto court to see, can I start to understand in a different way optimum performance? Imagine if we had a model of the jump smash or any other stroke. Now we don't have that at the moment, but that's certainly where we'd like to get to in the future. And then we could really start, rather than trying to look at things experimentally, theoretically explain that link between technique, strength, the racket properties and performance. So I've spoken a lot there, and I'm going to ask you all a question virtually. I've taught you we've talked a bit about performance and technique. So here's a sequence from a paper we published this year with a group in Malaysia, on some elite Malaysian badminton players. And these 2 sequences represent the fastest and the slowest data sets in that study. But which one do you think smashes faster? Is it A or is it B? Well, if you read the paper, you will find out, and hopefully you've committed your thoughts. So give yourself a pat on the back if you said A, because A is the fastest person in that study, whereas B, although they were still smashing very fast, was the slowest. But was that easy to pick from looking at that technique? And the answer, hopefully you're thinking, is no. And that shows that movements in badminton are very complex, but with biomechanical principles, we can really start to unlock that. And we'll talk about that more in a future webinar. So that's the end of my piece. I'm now going to hand over to Pete, who's going to talk about injuries.
Awesome. Thank you, Mark, for that presentation, and thank you to the Badminton team for inviting me. I'm Pete Orway. I'm a research associate at Loughborough University. I finished my PhD recently studying apologies. Yeah, I recently finished my PhD studying lumbar spine bone stress injuries in cricket fast bowlers and also lumbar spine adaptation in cricket fast bowlers as well. Unlike the others on this call, I'm not an elite badminton player, but I am a big sports fan, and I'm very passionate about preventing injuries in athletes using a multidisciplinary approach. So during this presentation today, we'll be looking at some research which has used a 4-stage method to prevent ACL injuries in field hockey players. My own research into cricket fast bowlers and where that is at in this 4-step process, and then just a quick look at where the badminton research is up to in preventing injuries. So you may be sat there thinking, injury prevention, why do we bother with this? You know, I'm only interested in performance. Well, I can give you 6 very good reasons to why injury prevention is key to enhancing the performance of your players. Firstly, you're looking after the athlete's health.
Pete,
It's very important to keep them in optimum condition so they can achieve peak performance.
Pete,
You want to optimize their development.
Sorry to interrupt you. I think it's not showing the slides that you are seeing right now. Can you try to reshare again?
1 sec. Apologies.
Don't worry, everyone, we'll get there. Yeah, right now we can see your screen.
Okay, excellent. Cool. Is that good?
Can you go to the other slide, please, just to make sure? Yes, excellent.
Okay, awesome. So yes, sorry about that, everyone. But as I was saying, injury prevention is key. So not only with athlete health, but also with optimizing the development, particularly of younger athletes, especially during late adolescence when they're making rapid growth and also strength changes. It's key in this phase to keep them on the court. We also can improve coaching by giving the most up-to-date research to prevent players getting injured and to try to feed back these strategies, whether biomechanical or physiological, into coaching practice. By keeping players on the court, it's likely that they'll improve their performance. It also saves money. Injuries are expensive. I think when I was looking over the badminton research, per injury in Hong Kong, it costs over 1,200 Hong Kong dollars per injury, which is an excessive amount, particularly if you have a large squad. And finally, equipment design also comes into injury prevention. So it may be, for example, in cricket, helmet design recently has changed over the years to prevent players getting concussions, and this may be used in badminton, perhaps with the shoe design or in the racket design. So what is this 4-step injury program? So the first stage of this is simply an epidemiological study. So it's just looking across the game to find out what the most prevalent and the most common injuries are. Once we know this, it's then possible to start to focus our research on understanding how the injury occurs, which is stage 2, the mechanism. So, for example, if a common injury, let's say, is a shoulder injury, we then focus on how does the shoulder move in a particular movement, and also what is the muscle activity or the strength components of the shoulder. So then we can start to really focus in on that. In the first stage, we can then start to look at how we can prevent injuries. So say that we have a shoulder injury and we realize that the players who get this shoulder injury, they have weaker muscles, then we can start to look at doing interventions. So if we improve shoulder strength, can we then prevent the actual mechanism of injury from occurring? And then finally, to see if this works, you put it into the real world. So stage 4 is implementation. So if we were to put this shoulder exercise routine into practice, does this actually reduce injury rates in a sport? So one example which has been all the way through this is field hockey. So looking at ACL injuries. In stage 1 epidemiology, this study looked at a 16 season of collegiate athletes and particularly in ACL injuries. And you can see that in team sports, ACL injuries is quite a lot higher, particularly in field sports. And as you can see here, female athletes participating in esports seem to be at much higher risk than men. And the prevalence of this injury was also found to be really high. So per injury, an ACL injury costs 250 days per injury. So it's a really important injury to try to understand more about and it doesn't just affect one sport, it affects a lot of different sports. So by knowing that ACL injuries are common in team sports, researchers have been able to focus on the mechanism of injury, and there appears to be 2 different ways that this ACL injury can occur. There's a non-contact version of it here. So in this case, if you look at the athlete's right leg, you can see that it kind of buckles under the athlete's own weight. And there's also a contact version where you can see in the second frame, there's a weight added to an individual's left leg, causing it to buckle. In both cases, the mechanism is really similar. It's just a high knee valgus during weight acceptance while landing, but it's really interesting in this case that it happens in both non-contact and contact situations. Further research has found it's not just the dynamic knee valgus alone. There's other factors which also relate to increasing this. So by having a greater ipsilateral trunk tilt and contralateral rotation, a more abducted hip and a flat and externally rotated foot were all linked to increasing dynamic knee valgus and ultimately the load on the ligament itself. From this, researchers realized, well, the best way to prevent ACL injuries is through reducing knee valgus. So there were 2 main ways to do this. The first is to improve strength and the muscle activation of the muscles surrounding the knee, or to modify technique. So this included the strength and muscle activation of the gastrocnemius and also the external hip rotators. And then to modify technique, the 2 options here were to increase knee flexion and to increase trunk and upper body control. Both of these combined are likely to reduce knee valgus and then to also decrease the loading on the knee ligament in question. So one researcher has taken this further and she looked at a hockey team. So firstly, they just followed them for a whole season and just determined the injury rates across that season. After this, they then had an intensive phase of training where they focused on enhancing the strength, activation, and also the coordination patterns of the athlete's knees. And then they followed this up with maintenance phases of this very specific training focused on reducing knee valgus in this hockey population. They then looked at the injury rates following this training across 2 seasons. And this is just a quick diagram of that. So it's really focusing on those stage 3 parameters, which we covered. And what they found is that compared to the control season, they found that after they did the intervention, they found no ACL injuries at all. And there was also a decrease in other knee injuries and and knee ligament injuries as well, showing that this intervention was effective at preventing ACL injuries. And this shows how research-led injury prevention methodology can be used to prevent injuries. What they also found was that total muscle activation and directed co-contractions, they found some small changes post the targeted training. So this is how the knee valgus was reduced, basically, that they almost retrained the hockey players' muscles to not put such a load on the ACL itself, which is really interesting to have that evidence alongside the actual injury data. So that's a great example from field hockey. Now I'm just going to go through my own research and where that's up to in cricket. So as Mark alluded to earlier, cricket fast bowling is one of the main sports which we research at Loughborough, and the biggest injury in cricket, the biggest burden, is lumbar stress fractures. So it has the biggest prevalence of all of injuries, although the incidence of this injury is quite low. The time loss is massive, and it's over 8 to 9 months per injury. So there's a number of risk factors to bone stress injuries. These include the load placed on bone. This includes things like an individual's technique, their workload, and their muscle characteristics. We also have the baseline bone stiffness itself. So this includes things like genetics, the sports which an individual participates in as a teenager, particularly, and their nutrition history throughout their childhood. And we also have the factors which have an effect on bone formation. These include an athlete's current nutritional status, their use of painkillers, and also if they smoke, drink, etc. Because of this, the ECB's medical screening program attempts to address loss of this. So we have a full biomechanical program here where we put all the development teams, so from under 17s through to under 25 players will generally have their biomechanics done at least one point in their career, so we can understand more about technique. We ensure that the elite players or players of interest will have a GPS tracker which they wear for all of their games, so we can calculate how much distance they're traveling and also how many balls they're bowling in matches and training. We also put players through a DEXA scanner if we want to know their bone stiffness at any time. It's a really good tool for quickly calculating that, and also gives us a great indication of their total health as well as their fat-free mass and fat percentage. So a really good almost MOT or checkup for any fast bowler. And finally, we also put the elite players through an MRI scanner to look for any signs of stress fracture. As the earlier which you see, any stress fracture, the sooner we can get players back on the park. So we're interested in how stress fractures happen, and one of the things which we looked at was technique itself from that biomechanical data. And what we found is that there were 2 factors which related to stress fracture, and these 2 factors combined explained 88% of all the stress fractures which we saw in our fast bowlers. So you can see on the left, what we're interested in there is hip flexion. So you can see that the player on the left has much greater hip flexion than the player on the right by about 25 degrees or so. The player on the left within 2 years went on to get a stress fracture, but the player on the right has never had a stress fracture. And the odds of the player on the left getting a stress fracture is about 70 times that of the player on the right. Similarly, on the players on the right hand side, we're looking here at the lumbar spine extension angle, and what we found is the player on the left again is more likely to get a stress fracture than the player on the right. There's only 6 or 7 degrees difference between these players, but that associates with a 9-fold increase in risk of getting stress fracture. So far, we've been able to identify players from technique at risk of injury, which is a really useful tool and something which we're looking to work more on in the future. We've also been interested in workload as well, another way of loading the bone, and the key findings in this was that just any period of high workload, whether that's over 7 days, 28 days or 90 days, is a significant risk factor to injury. But the single best predictor that we found is that bowling greater than 234 balls in a 7-day period significantly increased the risk of lumbar stress fracture. And it's this acute workload which appears to be very dangerous for bone stress injuries in general across many other sports as well. And then finally, onto workload. What we found here is that the players who had stress fractures had weaker bones. They had less stiff bones and therefore went on to get stress fractures as well. So from my PhD, we found 3 major influences to stress fracture. One, overall bone health, another technique, and the other workload. So 2 of those are quite easy to modify, being workload and technique. Bone health, a little bit harder, a little bit slower, but we're learning more as time goes on. So far, we've tried to put in some prevention measures. So from the workload research which we did, we looked at the different age groups and we came up with thresholds to try to prevent them getting stress fractures. So we used a rock curve here, and what we found is that if we were to say that players can only deliver 35 overs in a week, which is 210 balls, and were aged 17 to 19, 90% of them wouldn't get stress fractures. And it's the same story for 20 to 21 year olds with 38 overs and 22 to 25 year olds with 42 overs. We implemented this last year, which was sent out to all the coaches, and what we found last year was that there were no bone stress injuries in cricket, although half the season was taken out by COVID. So hopefully this year will be a similar story where we have a full season and hopefully see research in action, which is where we're at now with this research. So on to badminton. So where is badminton at in the research? So there's a few epidemiological studies out there, and what they all seem to show is that lower extremity strains and sprains are the most common injury, which is a great start, but there is a need for a prospective multi-year study to determine the specific incidence and particularly prevalence of specific injuries to improve the understanding of injury itself. Like, I'm sure the etiology of a hamstring strain is very different, for example, from an ankle sprain, but yet they are categorized as the same, and it makes understanding how the injuries happen a lot harder. However, from my knowledge of badminton, from what I hear from Mark and Harley and others, is that the most strenuous parts of badminton appear to be in the smash and during the lunges to reach low shuttles, and it's likely that during the landing and takeoff phases of these, that injuries to the lower extremity is likely to occur. So that's as far as I think the badminton research has got. It would be great to see more research out there so we can try to prevent some of these injuries. Thank you for listening. Apologies about the start of this presentation where there were some technical errors, and I will hand you back to Stefan.
Thank you very much, Pete. We have a lot of questions right now popping up, and it's quite interesting to hear what you have done into in the practical PhD research personally, and also how to transfer that further forward. My focus at the moment on my presentation is about what evidence-based approach to performance and coaching means. Harley already covered very slightly that. I would try to answer a little bit more, and the part that I would focus the most is the second. So what are our goals? Of course, we want to provide evidence-based content for coaches, players, and administrators, and we want to create an online market platform for coaches, scientists, and business leaders. The second part is more important than the first, when we want to help external coaches, scientists, and business leaders to create relevant content with required quality. Of course, we'll also create such content in different forms, webinars, video demonstration, presentation, and so forth. So what is our business model at that single moment? Now, we want to welcome everybody who has a very relevant content or which could be translated in a practical applied science, as we call it, to get in touch with us. And the business is quite simple. If you develop your own content, you own it. What is concerned as a background intellectual property. And if we help you co-develop that, as we already have courses that are ongoing in the development, where we are contributing together with the author of the research to make it more relevant, that's what is the foreground IP. Now, simply said, based on that model, that everyone could have earnings based on the course and the profit, which would differ quite a lot depending on how much is your own knowledge and how much we support it and what is necessary, but it will be minimum 60% and it could go up to 90% without any problem. And what do we deliver as part of that? We could definitely help with planning and creating the relevant market strategy and translate that in understandable language practically applied for the coaches. We also could provide all the tools to create the content, including the platform, all software necessary for that, including video specific software, any kind of a content delivery software, and of course, even the hardware for that. We could help delivering the all materials and anything required to that. And of course, our goal is to maintain justifiable quality on the highest level so that materials really make a difference, and we'll take the responsibility to promote it worldwide. So what this could be, what kind of content we're talking? Of course, simple form of content is kind of a blogs, which are promotional content. A type of webinars that delivers value, no matter if it's a promotion and free or if they're paid with a significant content value within the webinars. We're discussing about online hybrid or so-called blended courses, which could be, of course, free to some extent. And of course, they could be paid according to the COVID regulations in different countries, of course. Research articles and a lot more types. We're even discussing about apps on the iOS market and Android, which could actually solve a lot of challenge for researchers as well. This is everything from me. We're now going to the Q&A questions. You can see our contact details. Please don't hesitate to give us a call or write an email. We're quite accessible and we'll try to respond as fast as possible. I would like to ask all the presenters to unmute yourself so we can go through some of the questions and we can have a little panel discussion.
So the first question that we have is for Professor King, and it has been asked that what do you think is the biggest problem in the Smash today? Is there anything that could be improved very fast?
So it's great to have the $1 million question up front. I'm sure every person who plays badminton wants to be able to smash faster, me included, who had a particularly poor smash in his day. I think what we're seeing, and Harley, will answer this more fully than me in due course, is that people get to a relatively common position at impact. And that sequence I showed you earlier, where I showed you those two, one who smashed faster and one who smashed slower, it's the preparation and the bit before that, and where the racket is and the body at the lowest point, that perhaps is a more interesting point that's coming out as the differentiator to speed. I think it's not something we can go into detail here today, but I'm sure it will be the topic of a complete webinar in due course. And what we found, we've had a project with BWF going to the World Championships, etc. And there's another PhD student linked to that project. I'm not going to give a quick answer here, but Harley, is there any snippets you would give on that point?
Yeah, I think kind of like Mark said, we're mainly seeing that regardless of ability level and smash speed, that all players will generally achieve a similar position at the point of contact, but where we see the biggest differences are during the kind of maximum counter movement position. So generally the better players will have a greater range of motion in the counter movement positions, so mainly trunk rotation and shoulder external rotation. And what we essentially think that means is by achieving those positions, they can produce greater speeds of the body essentially once they reach that common point of contact, and ultimately achieve greater head speed and shuttle speed. So a lot of it is around the counter movement positions of the trunk and shoulder, as opposed to any major differences at contact.
And if you compare that to what I showed you in the cricket example earlier, think of that second factor, which was the arm position at front foot contact, and the bowlers who bowled quicker had a more delayed bowling arm. And I think it's not unsurprising that there's a similar, albeit different, mechanism happening here in the smash. And we see this in other sports as well. Think of golf, where there's a bigger X factor. Again, they get to a relatively common position at the end, but it's the ones who are able to get to that common position at the end but have a more counter-rotated position earlier that are able to achieve the high speeds. So the thing here is not to coach to be more counter-rotated if they can't achieve that position at the end. And that's like we see that in some of our spin bowling work as well, where so it's all about achieving a position at the end, but how far can you counter-rotate before then and still get to that position at the end? I hope that answers the question.
Thank you very much, Mark. We have a lot of questions, so we'll try to answer all of them, and I hope we have enough time for that. Now, the next question is, do you think the kids should be taught differently compared to higher lit players?
So I think the best person to answer this one is you, Stefan, at this point in time.
Yes, so I have an opinion as a coach about that, which is yes, but so simply said, yes, they could be taught differently. But the difference comes that every technique is related to the next level. So simply said, I would definitely agree that they should be taught differently. And a very young kid on 5 years old can't really make a full jump smash without making the foundation for that. And we can go to really a lot of details, but I think there are also a lot of other questions that are quite interesting. Next one to Professor King. Could you give us some methods that kids could learn forehand, overhead motion easily and correctly?
From my research, no. And Stefan, perhaps you could want to answer that one as well.
So practically as a coach, yes, I don't think we can present it right now, simply because there is a different methods to teach that. But we'll definitely address that a lot more in a further webinars, as well as some content in the course that is upcoming, because that's exactly where we want to go. We want to answer very specifically what does it mean proper teaching and how to do it easily and correctly. Okay, next one to Dr. Owe. Have you got any experience if there is a significant difference between injury types in different environments around the world? From David McDonald.
That's a good question. I think I'm not aware of injury rates for different injuries differing around the world. Like, my expertise is in cricket, and sadly most of the research into injuries in cricket either comes from here or in Australia. What I will say on bone stress injuries is that there is an ethnicity component to bone strength itself. So in running, for example, African American athletes are much less likely to get bone stress injuries compared to their Caucasian counterparts. So it may be that if you were to look around the world, the injury rates would reflect this. I guess there's also the cultural factors. Like I know cricket here, we generally monitor workloads quite well, and we restrict players from bowling what we think are excessive workloads. But it may be that in other countries they have a different culture where it's more just about letting people bowl whatever they want to, which may lead to different injury patterns as well.
That's great. Thank you very much. Thank you very much, Pete. I think next question. So again, we have a lot of questions, which is great. Badminton technique evaluation is very important to find the mechanics of injuries. Also, risk factors such as physical dysfunction has been reviewed in other sport. So what do you think about physical fitness evaluation in badminton players? I guess if this is related to injury. So maybe Pete, you can start with that, and Mark?
Yeah, sure. So I think, as you said, like technique evaluation is really important. I think with a lot of injuries, there is a technical component to it. So as you saw in the cricket, fast bowlers, we're interested in the rear hip and also in how the lumbar spine extends. The next phase of our project is trying to find out what physical components relate to those movement patterns. And I think that's a very powerful tool for coaches, and particularly S&C coaches, so then we can target these movement patterns. So what we really want to find out is that if there is a strength component which relates to those injurious movement patterns, if we improve that strength characteristics, then does the technique change, which then reduces an individual's chance of injury. And I would think in badminton it may be something similar with like ankle sprains, etc. I don't know if Mark has more to add from a more badminton point of view.
So I'd say the research is ongoing, and one of my other PhDs that Daniel Fong is supervising in the main, Harry Wang, is looking at forensically analysing ankle injuries in competition, and he's about halfway through his studies, and I'm sure in the future we'll have a full webinar on ankle injuries and also preventative mechanisms for that as well. But certainly technique is a clear important component. And if you look compared what Pete presented on the knee injuries, and then think about how that might equate to badminton and knee injuries, where that can lead to a substantial loss of playing or training time, then I think there's some learnings we can take there. But what would be the particular techniques from a badminton perspective?
That's fantastic. Thank you very much, Mark and Pete. Another question from Amy Lloyd. Badminton by nature being an intermediate activity, do we have any data from pilot study or any others on the optimum recovery time between rallies? Generally, there is about 1-to-3 ratio in ball in play and not in play. So maybe Harley or Pete, I don't know if we have any studies on the recovery time.
I don't know the answers to this, but I know there's in physiology we are doing a bit on this, and one of my colleagues has got some pilot work in this area, but I haven't got the results of that to hand. Perhaps we can get in touch with you, Amy, afterwards to show you where we've got to on that. Yeah, that will be absolutely great. Yes, Pete, if you have anything to add?
Yes, I think one of the things with technique is that if a player's in a fatigue state, it may lead them to alter their technique and to put more stress on the tissues surrounding a joint, which may increase the risk of injury. But my research isn't in badminton, I'm afraid, so I'm not sure about the exact ratios for the recovery.
Maybe I can just answer something additionally for that as a coach. Experience on the individual recovery times measured by heart rate variability has been quite efficient in my experience. So simply said, individually detecting what is the best recovery time, and if the person is working in the optimal training zone, therefore the risk of injury, we assume it's minimal, but again, we need more data and much more piloting for that. That's just by experience at that single point. Thank you very much for the question, Amy. Next question, can biomechanics in terms of strength, angles, etc. be applied in sport practice of people with disabilities? That's a great question.
Yeah,
Mark?
and yes, and absolutely is the answer. So we've not looked at this in badminton, but we have in wheelchair tennis, and Christina, one of my other students, is just finishing a PhD, and Yash is about to start his PhD on wheelchair tennis. And you know, the constraints placed by disability or lack of strength, etc., or movement and ranges of motion will affect what is optimum. And of course, we can use biomechanics to understand what then the optimum is. So, for example, if someone's in a wheelchair, the net, you know, is at the same height in badminton, or I think it is, and that makes, you know, what's possible very different. So it becomes a different game, but we can start to explore those limits of performance as well.
That sounds great. Thank you very much, Mark, as well. Next question. From Hiroki, Professor King, badminton smash is more complex technique than cricket bowling. How would you transfer your experience in cricket to badminton smash? I think, Mark, you already answered partially to that question, if I'm right.
Yeah, and I think what you'll see over the last proportion of the smash, for example, is that it's quite a planar movement. The racket's moving in a forward plane, and actually the mechanics and mechanisms behind it, I don't think are that different. No, the principles about how you make an object move fast are the same, irrespective.
That sounds great. A question to Pete from Ronnie. What is the best and most scientifically proved workload monitoring technique in cricket? What do you suggest?
Sure.
Thanks.
Sure. So workload is probably one of, I guess it's a very topical area at the moment, and there's some debates between research groups to whether just raw workloads, so like a 7-day workload, is more effective than like using any ratio. So the most popular of that is the acute chronic ratio, and there's good evidence either side. I'd say, you know, use whatever's simplest for you. So some of the coaches I work with, they're big fans of just using 7-day workload because it's really simple to use, while others, they prefer going a bit deeper into it. I will say the most important thing of all with any workload monitoring is understanding the individual athlete, having that history over time of their workloads and how that's related to when they get injuries is really important for setting where their upper limits are for what they can tolerate, and then from that it becomes a bit easier to prescribe rest into their training programs or their match cycles.
That sounds very clear, Pete. Thank you very much. Another question from Fonseca Keiko. Models usually present limitation on representing some variables as a trade-off for the model solvability. And then it's, of course, complexity, scalability, processing power needed, for example. Would you please elaborate about the limitation of your simulation model of the jump smash? Does the model implementation set an upper bound speed to the smash speed? I guess, Mark, could you
So
please...
the simple answer is the limitation is we don't have a model of the jump smash yet. It's one of the things we definitely want to do. But if I talk more broadly, then we build models that are specific to the activity that we're interested in, and we show through the model evaluation that we've represented all the important components in the model for that activity. So a model of tumbling would be different to a model of cricket fast bowling, for example, would be different to a model of the jump smash. So, we're not limited by any of the things you talk about there, but what we do is restrict a model to the things that we have found to be important. And if we get it wrong, then the model doesn't work and it doesn't evaluate appropriately. So I hope that answers the first part. Does the implementation set an upper bound speed to the smash? Well, all else being equal, yes, it will in the end. But just like we find in cricket fast bowling, our models get up to about 100 miles an hour, and guess what? People bowl to about 100, bit like the tumbling where the triple layout. I don't know what that number is for the smash, but it's not going to be very different, I don't suspect, to where we are with the current, elite performers around the world.
Thank you very much, Mark. A question from Sheen. Injury prevention. How do you consider the trade-off between performance and injury mitigation in a practical settings? Like example, valgus, femoral, internal rotation, and pronation may be beneficial for performance. When might you decide you need to step in with an athlete? Maybe Harley or Mark. I don't know, Pete. I don't know who.
I think this one's Pete.
Yeah,
Pete,
so I mean, This is a very, very challenging question. So, I mean, as someone, I'm very interested in injury prevention, but I also understand when coaches are like, if I tell them that a player needs a rest or something, or they might benefit from changing their technique. It's a difficult conversation to have, and of course, there's that trade-off between performance and injury. But this is why, from our research, this is why we're quite interested in the physical characteristics. So rather than actively changing someone's technique, our hope is that if you were to strengthen the muscles surrounding a joint in question, which is related to a particular injury, the technique would change without actually manually changing the technique. So they become safer in their technique, don't lose any of their performance characteristics without actually physically changing their technique. This may just be, a dream of mine that it works so well, but we are quietly confident, and hopefully in the next couple of years we'll have some data on that.
That's great. Thank you very much, Pete. I'm conscious of time, so I know that we're over the 2 o'clock already, so we'll just answer a few more questions, and I'm really sorry if we can't answer all of the questions, but we'll try to respond to that via email or anything additional after that. Interesting question. Does your business model include sport analytics to improve match presentation and commentary, for instance, rally time, rally density, speed and placement of rally, etc.? Maybe I should answer that question. So the business model includes all the tools that are required for such work, but the analysis at the moment is not done in a lot of aspects. So if we, like in example, compare different models at different levels, that answer would be different to the level. So yes, we can provide the tools that somebody could assess that. However, we don't think that there is any assessment at the moment to all the possible levels. And I hope that answers the question a bit about the business model. Amy Williams, when looking at injury prevention methods, how do you ensure any of the implemented methods do not limit the player's performance ability? That's a great question.
Cool. I think I covered that in my last answer. Like, it's got to be a balance between the coach and the physiotherapist or whoever is working on the medical side with an athlete.
Thank you, Pete. Another question, what could badminton offer in the future, certified courses, etc.? Of course, I think I covered just small content, but yes, we're talking about certified courses. We're talking about a content that is academically filtered to be scientifically evidence-based content. So something that you can apply, but you can also count that there is a relatively high-level science within the content. So somebody has checked it, so it's not some kind of I wouldn't call it fake science, but something that is more just than just a normal level, if I put it very shortly. We have a comment that the experience as administrator that most of the injuries are around ankle and hamstrings. I guess we'll have to go back to Pete discussing about how to do a better studies for the badminton. Maybe last question. From Phoebe Davis. Good afternoon, Dr. King. Your thoughts on the influence of the velocity or counter movement before jump smash on performance, racket speed and smash velocity? Thank you. Mark?
I think they're two separate parts of the movement. So the counter movement jump and then the performance of the smash. So I see them as separate. It's almost like a jump and then the smash. I think they're separate, but the counter movement of the upper body, I think that's important, and that's where we were talking about earlier. So we think that really is linked to endpoint speed.
That's great. Thank you very much, Mark. Thank you very much to all the presenters first. It was fantastic having you. Thank you everybody who joined us today. I really apologize that we haven't been able to answer all of the questions. We'll try to take that. Additionally, as far as is anonymous, it's hard to answer to something specific, but please get in touch with us. Don't hesitate, just write us, drop us an email. We will try to respond as fast as we could. And I hope you have a wonderful day, wherever you are in the world. Thank you again.
Thank you, everyone.